All right, I'm going to go ahead and open up my Rhino file. Let's go to Workshop. Let's go to Camper Trailer. No, I'll go and open this up. Let's see, date modified. Let's do this one here. One thing I wanted to show you all was I made a little folder here called Purchasing. And inside that folder, I've thought about two things, doors and a roof vent. So if I look at my doors subfolder, I've got an internet shortcut that I pasted in here. So let's go ahead and click on that. Open up Google Chrome. If you visit recpro.com, it's a great place where they have all these RV camper windows and doors ready to go. So you can purchase one here. This is a single hung window and a door. And it also gives you all the dimensions that you need and a price, which is really important. Lots of pictures. Kind of shows how it works. It's kind of curved. There's your rough dimensions right there. 26.5 by 36 and an eighth, or 26 and an eighth, I think, by 36 and an eighth. So there's some doors that I found. If I go back, I went ahead and took some screenshots of those things so I can just have an image of these things and I can refer to it at some other point. I don't have to just go to that one website. There's that shot, and there's just a perspective shot showing me what it kind of looks like, just in case I want to 3D model this a little bit further and show more detail. But for the scope of this class, we're not worried about 3D modeling everything to the smallest minute detail, right? I don't need to see that it's a single hung window. I don't need to see the latch. I don't need to see the screws. I don't need to see the gasket, the rubber gasket around the whole thing. I just need to know the rough dimensions, which was the other image, this one right here. Right. So these are the actual, this is the actual window dimensions overall with all the accessories and the gasket and everything. But this is what's called your rough opening. So 36 and an eighth by 26 and an eighth, that's what you actually have to frame for. So this is why it's really important for you to pick some of these items, a skylight, a door, a window, a fan. You need to know these dimensions so that way once you get into Rhino, you can plan where those things go. Once you get into Detailer, you can even further plan where these things go. Maybe make some last minute decisions and change where that goes. But we can't just throw numbers in the air and then just FrameCAD Detailer this thing out, print it out, and then go buy the doors, right? We can't make the doors fit to whatever we drew. So find real products for your stuff. It'll actually help make the design process a little bit easier for you because it's giving you set dimensions. Here's the roof vent. So if I go to this, it's also a website. And I wanted to go with a roof vent that I could just pop open, but I can also have either on a sensor or on a remote or just by toggling on and off the switch an actual motor and fan that will help propel any of that hot air inside of my cabin straight up, right? Hot air rises, so I'm just helping it go up and rise faster. Additionally, the component that stays on the interior, on the underside of the camper trailer, inside of my unit, has LED lighting in there as well. So this is like a 3-in-1 combo. I can have the fan on, I can not have the fan on and just have the cover opened, and I can also turn on the lights and have my own reading light or whatever I need. And it's $280. It's really not that bad. 6-speed as well. So again, we're looking for something that shows us dimensions. So here's an image showing you some of these. These are the actual dimensions that we want to use. Okay, so once you start to find some of these things, now we can get into Rhino and figure out where we want to put these components. So let me show my Rhino file now. Okay, so here's my Rhino file thus far. I've kind of figured out, okay, I need a door on one of my side panels. I want to make it sort of a teardrop shape, but I understand that I'm using FrameCAD. I'm using FrameCAD for this design, right? FrameCAD is not compatible with curvatures, right? It's not going to do curves very well. And a teardrop trailer is very curvy. So with that in mind, I've decided to make my life a lot easier and just made a lot of sharp angles and chamfers and just straight lines, so as many straight lines as I can without it being too rectilinear, too boxy. Okay, so it's kind of teardrop trailer shaped, but also not. It's faceted. Okay. So that's just the outline. As I begin to turn on some of my layers and sub-layers, here is just in 2D, just like we did at the beginning of the semester. This is a two-dimensional shape, right? It's just lines at a very specific distance apart based off of a drawing that I found of the actual trailer, right? I could fit a 4-foot by 8-foot bed on the trailer. As I turn on my next few layers, I even started to 3D model the trailer. It's a little unnecessary for what we're doing, but it just adds to the realism. I do not expect you guys to 3D model the trailer unless it's very important to your build. Right? If some of you are actually considering doing this project for real, and that's really cool, and I support it. And you can use software like this to help figure out your shopping list, which is what one of you is doing, which is awesome, right? And this is just another way. Rhino is just another way of getting your ideas from here to your hand to on screen, and it'll help you generate your shopping list. It'll help you communicate your ideas to your client or to your team. So no need to 3D model that. Here's me 3D modeling the tires just like very roughly. I don't know what I did was like 33-inch tires or something like that. I'm thinking some beefy off-road tires. That you might want a 3D model if that's important to your build, okay? Because it was important to our build for that camper trailer that's outside. We actually had the wall sneak up and around the wheelbase, and then we actually had to fabricate our own little what do you call it? The wheel well thing. Yeah, thank you. It's just aluminum that we scored and bent into shape, and it kind of works. All right, so model what is necessary for your build is what I would say. Here's a layer where I'm just putting on 3/4 inch or 1 inch thick plywood. Right? I want something nice and rigid that's going to help hold that trailer shape, even though it's all welded and structural steel. Another sheet of plywood is going to help. It's also going to help me start to build up a cavity, a series of cavities underneath to which I can insulate that. If you really want to build this thing, don't forget to insulate the floor. Right? Leave room for that. This next layer is just a big box. Right? What you'll notice in this exercise is I use the box command 100 times over and over and over again, and I'm just showing you 3 5/8 inch boxes versus 1 5/8 inch boxes versus a 1/2 inch plywood box. Everything in Rhino almost everything is just a box in Rhino. Now, as I turn on my design layer, okay, within that layer I have my FrameCAD steel. So this is sort of what I'm imagining being the steel component, or really I'm just thinking about things as walls and floors. Walls are things that go up and down. Floors are going horizontal. Floors and roofs I'm using those loosely and interchangeably, okay? So even what's on top there, floor, roof, whatever, it's just a horizontal plane. Now it still might have a pitch, it might have a slope, it might drain in a certain direction, but for all intents and purposes, walls versus floors. So I've got one wall here, 2 walls there, I've got a wall back here, and I've got one wall right there, okay? And that's pretty much what we did for our camper trailer. That's all it took as far as FrameCAD goes. Okay, so I want you to keep that kind of stuff in mind. So how did I make these big holes, right? These holes here represent my doors. I want 2 doors. This one up here represents my fan. Who can tell me what command will allow me to make those holes in my walls and floors? Boolean difference. Well, that's also correct. What is it? Extrude what?
Extrude cut.
Extrude curve.
Cut.
Extrude cut?
Yeah, instead by extrude.
Okay, you could be right. Is that like, that's probably a new Rhino 8 feature?
I mean, like you draw a sketch and you cut through it.
Uh,
Extrude the boss base or extrude cut boss base that where it's not cut through it.
in Rhino.
I think so. Or Boolean.
You could be right. Yeah, Boolean difference is
Boolean
my
is when
go-to.
you make the shape in Boolean.
Yeah, Boolean difference is my go-to. Let me show you what I mean. I'm going to take this one wall that I've already punched a hole through, okay? I want you to write this command down, isolate. Select one piece of geometry, type in isolate. That's a super important command in Rhino. What does it do? It hides everything else besides what I selected. Why? Why would I want that? I want to focus on just the one thing at a time, okay? My mind is spinning, and if I see so much geometry all over the place, and I've got all my O-snaps on that I love to have on, I'm just snapping all over the place willy-nilly, okay? I'm so simple-minded. I'm just so linear. I just want to see one wall at a time, okay? So isolate is a great command. Another one, ZSA, okay? Zoom, select, all, okay? So whatever I select, I'm just going to pre-select it, and I'm going to go far away from it, okay? I'm in Mercury right now, looking at my camper trailer, all right? ZSA, zoom, select, all, and it zooms in to what I selected in all 4 viewports. Okay, even though I'm just in the one viewport, I'm only looking at one viewport. ZSA, okay, zoom, select, all. So, and what that helps too is that your camera is like fixated on that one thing that it had to zoom into, right? If you've ever had that condition where you're like trying to zoom in and no matter how far you zoom in, you'll never actually get to that point, and then all of a sudden it just disappears. That's because your camera, your Rhino camera, is not honed in and focused on that one thing. So if you type in ZSA, that's your little cheat code to like, hey, camera guy, focus on that thing and let's get closer to it and zoom in, zoom in, zoom in. All right, ZSA. So I want to work on this one wall. I'm going to return this wall back to its rightful glory real quick. This is not really something that you need to know, but you can observe me doing it, although I'll be done before you know it. Let's align this. Oops. Okay. Delete. All right, here I am in perspective, okay? I have the basic overall shape of the body of my camper trailer, of one elevation of this camper trailer, and I also have my door. So I'm going to do this in 2 different ways. I'm going to give you 2 varieties of how to puncture this wall. First thing I'm going to do is with this one, I'm going to extrude it 3 5/8, right? And this one, as you can see, does not have that hole. What I'm going to do is I'm going to take this rectangle that represents that hole, that door opening. I'm going to extrude curve that. Extrude curve. CRV. Okay? And I'm just going to make it way too long. Like so silly long that I know it doesn't belong there. Okay? That's how I like to think about it. Because if I just make it exactly the right width, like 3 5/8, sometimes Boolean difference won't work if things are not aligned properly. I like to exaggerate it and make it too long, and then I remember to delete it later on. Okay, so Boolean difference, please write that down. Boolean difference. Okay, it is the subtraction of one solid polysurface, a closed solid polysurface, from another one. Okay, they both must be closed and solid and polysurfaces. Okay. So the way the command works is you type it in. The first thing it's going to ask you is, please select the surface or polysurfaces to subtract from. So that's going to be this wall. I'm going to subtract from that wall. The result of this thing is the wall with a hole in it. So I want to keep the wall. So the wall is the from part. Okay. I'm going to press enter to continue. Now I need to select the polysurfaces to subtract with. That's going to be this big block of cheese that I just made. That one right there. Optionally, in this subcommand, it says delete input equals no. If I leave it as equals no, it'll keep all this geometry here, and I can manually delete it on my own. If I click delete input, it'll switch and say delete input equals yes. It's going to delete that cutting object, that second object that I click, okay? So I'm going to leave it as delete input yes. I'm going to hit enter, and there you go. That's how you punch a hole from that solid wall. Alternatively, if you have the closed curve boundaries of these two things, you can select both of those curves, extrude curve, extrude it 3 5/8, and no Boolean operations necessary. Okay, same result. They're both. If I select one, this is a closed poly surface. If I select this one, it is a closed extrusion. Not too much of a difference between those pieces of geometry, but you know, it does both yield the right results. Okay, so one thing that I was talking about with some of you today is once you have your, I'm going to type in show to get everything back, right? When you isolate something, you're basically hiding everything else. So the opposite of that is show, okay? So in your notes, where you have the word isolate, somehow annotate that the opposite of that would be show. That's how you bring it all back. Isolate versus show. Okay, so now I have a red wall. Doesn't really matter what color it is. I'll go ahead and select it, right-click the correct layer, and say change object layer. Now it's on the correct layer, it's the correct color and everything. I want to talk about studs. Once you have a pretty basic understanding of how this thing is going to be put together, of what is a wall, what is a floor, what do I need, it's time to start thinking about your studs. Okay, so I'm going to select one of my walls. I'm going to hit isolate. I'm going to type in ZSA, and I'm going to, I like to make new layers when I do new things. I like to keep everything super neat and tidy and organized. I'm going to call this one CFS, okay? Cold form steel, CFS. Make sure you put that in your notes, okay? CFS, underline, underline, underline. That's the whole point of all 3 of my FrameCAD classes is cold form steel. It is the way of the future. So, I've got my new CFS layer. I can give it whatever color I want. I'm going to go with red, something super obvious. All right. I'm going to make sure that that layer is active. Oopsies. Oops. There we go. That's a little bit better for, that's a little bit better for those of you that are here. All right. Make sure that that layer is active, CFS, by clicking right here in that column where that check mark is. Bring that check mark down to your layer. That makes that layer current. Okay. So now whatever geometry I add into my model, it'll be in that layer, and it'll bear the right colors and line weights and everything. So I'm just going to add studs. Okay, and the one thing I want you all to pay very close attention to is the orientation of the studs. I'm starting to see a lot of you have the orientation going the wrong way. Okay, in regards to this panel here, this wall, right? This right here, from here to here, is 3 5/8. Okay, so I'm going to choose the box command, and my preference is the 3-point box. Okay, 3-point box. I'm going to select this point here, this point, which is 3 5/8 away from that point. I'm going to go off to the distance this way, 1 5/8 inch. Okay, I'm going to click, and now I'm going to define how tall to make that stick. And for this piece, it's just going to go right to there. Okay. Now I'm going to go to another view. Okay. It's fun looking at your 3D model in perspective view, but trust me when I say it's actually better for you to look at it from one of the orthographic views. Okay, so if I go back to all 4 viewports, this is my top view, this is my front and my right view. I would use the front view in this case. I'm going to select just that one stud. If you make a selection window from left to right, it'll only select what's fully encompassed by that boundary. And there's many ways we can go about this. There are many ways to skin a cat in Rhino, is the weird saying. But there's so many ways to accomplish the same one task in Rhino. We could do it in a million ways. I'm going to copy this one stick that I've made from one point, and I'm going to go 16 inches the other way. Okay, I want to space these studs 16 inches on center. Okay, make sure you jot that down. Studs 16 inches OC on center. So I've typed in copy. I've selected the thing I want to copy. At this point, I can select any point in this front view. So I'm just going to select some random point right here. And then I have ortho on. I'm going to move my cursor to the right. I'm going to type in 16 inches, hit enter, and then just click once, and it'll successfully copy that stick over 16 inches. Okay, that's one way of going about it. A slightly more advanced way of going about it, still not super advanced, is a command called array linear. Okay, make sure you write that down. Array linear. ARRAYLINER. Sorry, LINEAR. Array linear. Okay. The way this command works is it'll make a copy or a series of copies of my original object as many times as I want, a specific distance away from one another. Okay, so I'm going to go ahead and maximize this front viewport. For number of items, I'm going to say 10. I'm going to make 10 copies of this second stick that's right here. First reference point, any point here in this front view. I'm going to click once. With ortho on, I'm going to drag my cursor to the right, type in 16, hit enter, and then just click once as long as it's going in the right direction. And voila, I have 10 copies arrayed 16 inches in distance on center. Okay. Why 16 inches? That is just a very typical spacing that you would use when creating a building. With light gauge steel, we could actually nudge that over to about 2 feet, every 2 foot on center, which means we'd use less steel. But I'm going to keep it traditional and go with 16 inches. All right, so these sticks are all too short, right? They need to reach all the way up to here. Here's how I'm going to fix that. First thing I'm going to do is I want to select just a stick, but I keep getting this little dialog box here. All right, everyone, please watch up here. This is a screen that I know a lot of you are getting. I want to make sure you understand what it means. Okay, when I put my cursor right in that spot where you see it now, I get that little dialog box that says selection menu, extrusion or extrusion. Which one do you want? What it's saying is that right where I've clicked, there's 2 things that exist right there in front of my cursor, and I just have to pick which one I want. It's showing me the layer color of where that extrusion came from. One is red, probably because it's CFS, and one is like a nice dark navy green, and that's like a FCAD steel. Okay, I'm going to say this red one. I can also come over to my layers and say, hey, FCAD steel on my frame CAD panels, I'm going to lock that layer. Now I can't manipulate that thing anymore, right? I'm never going to accidentally select that thing anymore. Okay, so that's a really good hint. Lock certain layers. So I'm going to take this stick and I'm going to use a command called scale 1D. Okay, make sure you write that down if you're taking notes. That is one of the most important commands in your Rhino arsenal. Right. And what scale 1D does is it scales an object in only one direction or dimension, right? So if we have length, width, height, it's only going to scale it in one of those. Okay? So I've initiated the command. My base point is going to be this bottom end point. Make sure your O snaps are on and you have the correct O snaps on. Here are mine. End, near, point, mid, center, intersection, perpendicular. Have those things checked on. Now my first reference point is going to be the very top, the very end point of that stick. I'm going to click on that. That's my first reference point. And then my second reference point is where I want that first reference point to move to. Right? So if I hover my cursor all the way up to here, right? I've now stretched that one stick in that one direction. Okay, I'm actually going to do that again because it's a little too long. I went the wrong way, so I'm going to do that. From there on out, with those few tools, you just go around and scale 1D all of these items. Scale 1D, base, first reference point, second reference point. Scale 1D, base point, first reference point, second reference point. You can even do multiples of them at the same time. I can say all of these, scale 1D, from here to there to here. You can affect them all at one time. Okay. I would only do that if they're all the same size. All right. So now I'm going to move this one over, so that way it's on the outside of the opening. I'm going to move this stick out this way so it's on one side of the opening. I can see I'm going to need to scale 1D this thing down, and I'm going to need to scale, let's see, which way is this one going? This one's not even in the right spot. I'm going to move. Move is another amazing tool for you to know in Rhino. It's the basis of it all. All right, now I just need to do this angled piece, this horizontal piece, this angled piece, this bottom one, and this top one. So to do that, I'm just going to take one of my sticks here, or maybe one of these here. This little thing that I have that's red and green and blue, this is called the gumball. Make sure the gumball is on. It's a very helpful tool. Sometimes you don't always need to use it, but make sure gumball down here at the bottom is on. You can use this arc to rotate this piece, and if you have ortho on, it'll rotate it at a very specific increment. I have mine set to 45 degrees. Or if you don't want to turn ortho on, type in rotate. Rotate this piece from here to whatever degree that you want to rotate it. I'm going to rotate it 90 degrees. I'm going to move it from here, this endpoint, to that endpoint. I'm going to scale 1D from here to there to there. I'm going to take another piece, like this one here. I'm going to move it from this endpoint to this endpoint, rotate from that point to this near point. I'm going to scale 1D from here to there. Before you know it, I'm almost done. Let's move this one here, there, rotate from this endpoint to this near point to that near point. I'm going to scale 1D from this endpoint to this one to there. Okay, now I need my bottom plate. I'm going to rotate from here to there. Let's move this into place right there. Scale 1D. Okay, I'm not super concerned about these sticks intersecting with one another. That's totally fine here in Rhino. This is just a 3D sketch at this point. And if you wanted to 3D print this piece, it's not going to be an issue either. 3D printing will slice and sort of average out what's solid and what's there. So Don't worry about that. It's when we get to detailer that we're going to actually detail how those connections are made. All right, I'm going to take this horizontal piece, I'm going to copy it from here to there to here. I'm going to move this one down so it's around the opening. I'm going to scale both of these in 1D at the same time. There you go. That's basically my wall there. Now, if I wanted to, I can copy this horizontal one, move it up a couple of feet. That's about 1'8". That looks nice. Oops. Let's try that again. 1'8". Okay. Now I've got a nice horizontal member. Okay. Scale 1D from here to here to there. Okay. Let's make a copy of that guy. Put him on the other side of the door. This is going to offer some rigidity in this wall. Keep it nice and sheer and taut, rigid. Okay. I can also introduce some angled pieces if I wanted to. Let's take one of these and let me move them over here and click them over here and scale 1D from here to there, right? We saw Jason use angled pieces in his project. In detailer, it'll actually give you a header above your openings, but if I wanted to just add a little bit of extra detail, maybe I take this guy, copy it. This is so unnecessary, but if you want to get more of that feeling of what, a truss header might look like, that's kind of good enough. I'll put that over there. Scale 1D this guy a little bit. That's good enough. It's not correct. It's not mathematically correct. Okay, ZSA. Let's look at it in perspective. I like to check my work not only in that orthographic view, but I want to make sure that in perspective I didn't go wonky. Okay, I'm going to turn off this green layer, FrameCAD Steel, and voila. There's my actual FrameCAD panel wall with the opening, with the header, with an angled brace. No curves, right? FrameCAD's not happy with curves, but it loves sharp angles. Okay. If I turn on the rest of this project and use show, at some point you could just start to delete some of these walls. I wouldn't delete it, I would just hide that layer, but that's kind of a preview of what that wall looks like. Guess what? In my design, that wall is also on the other side. I made it easy for myself, right? So what I would do is if I hit undo a couple times, I highly recommend you select all of your red FrameCAD Steel, your CFS, and type in one of the best commands ever, group. Make sure you write that down, group. Super handy command. What does it do? Once you group everything, if you go to select one piece of it, all of them get selected. They will all move as a unit now. They're all one team. Okay. So in regards to the rest of the design, it's just the same thing over and over, just going around your openings, right? In Rhino, we're able to be a little bit more flexible, more malleable with our design. We can make different design decisions. It gets a little bit harder to do this kind of stuff in detailer. We want to finalize this here, play with the idea here, and then go to detailer, and right after detailer, go and print this project out and just be done with it and just have it right there and take it out to Joshua Tree. Okay. Once you get it to this level, next week we're going to talk about how to make the little small physical model of it. We can scale this thing in 3D down to the correct architectural scale. You'll be left with a nice little scaled model, which you can put in your portfolio maybe as a one-pager, right? I'm going to show you how to make your own little entourage to go right next to it. You're going to have a little John, a little Trung, a little, Reed right here next to him. 6-foot Jojo right there. And we'll get into that next week, but I want you guys to get this to this level of detail, right? Which is still not a lot of detail. It's just figuring out where the sticks are. That's it, okay? You might go through this exercise and realize, man, why did I put so much curves in it? Change your design. hard lines, chamfers, right? FrameCAD does not do curves very well, okay? You can't heat up FrameCAD steel and bend it, right? It's not like wood. It's not that malleable. All right, any questions? All right, I'm gonna leave this, I'm gonna publish this onto YouTube, and then I'll publish the link on the assignment. This will be due next week. Okay? All righty.